In this video, we are going to see how to solve the integral of the function 1 over x plus 1 dx. In one of the earlier videos on basic integrations, we have seen one integral of the function which is very similar to this function. That is the integral of 1 over x dx, which is ln x absolute value plus c. So this is one integral, one known integral. And this will actually help us a lot because you can see that the only difference between this function and this function is that x plus 1. But these two functions are very similar. In cases like this, we want to have a substitution which will help us reduce the integral which we don't know to an integral that we know. Therefore, here we have the substitution x plus 1 equals t. And as you know from some of the previous videos, we need to find the differential of these two functions, and those are the derivative and the derivative of t times dt. In this case, that's very simple. So the derivative of x plus 1 is 1 times dx, and the derivative of the second is again 1 times dt. Therefore, dx equals dt. And we have x plus 1 equals t. Now we have almost everything what we need in order to solve the integral. Therefore, the integral of 1 over x plus 1 dx will become, with the substitution, 1 over t dt. And if you have a look at this, it is the same as this integral here, and that is ln of t plus c, which when we go back to our substitution, we can write ln x plus 1 plus c, the absolute value, of course. Therefore, we can conclude that integral of 1 over x plus 1 dx is ln absolute value x plus 1 plus c. So this is our integral. We want to see here one generalization, which goes solve the integral of 1 over x plus 1 dx. Sorry, here should be x plus a. So x plus a dx, where a is any real number. If you want to try on your own and pause the video, you can do that. And we'll just see the solution, which actually follows all the same steps as in the case of, so a equals 1, I will just say a equals 1 solved above, which is obvious. So the obvious substitution actually is x plus a equals t, and then dx equals dt, and therefore the integral becomes 1 over t dt, which is ln absolute value of t plus constant c, and that is ln x plus a plus c. There is yet one more generalization that we can do. So let's say generalization 2. That is, if we have an integral of ax plus b, dx. Again, you can pause the video and try on your own. Here, the substitution will be ax plus b equals t. Now, the difference here is that x is not anymore alone. That is a coefficient. So ax plus b prime dx equals t prime dt. This here is a dx equals dt. And dx is therefore 1 over a dt. Therefore, the integral, which we call I, becomes 1 over t and dx. So this is our 1 over ax plus b. And dx is now 1 over a dt. That's the difference. If you have a look here, our dx was same as dt, but now there is a difference. So, but this is the constant and it can go in front of the integral. Now it is again the same integral that we know, and that is ln absolute value, and that is ln, what is t? It is ax plus b plus c. So this is our integral. I will at the end just write here is ln, and the integral is ln absolute value of ax plus c, and these two integrals we have solved. And you can immediately see that these integrals can be then, if you have a equals 2, b equals 3, this is the integral of 2x plus 3 dx. And using this formula now, you can simply calculate that is 1 over 2 ln 2x plus 3 absolute value plus c. So always when you solve integrals or any mathematical problem, try to think of generalization.